Hello everyone, welcome back to another video. Today's video we are going to series up all the packs on the battery shelf. We're going to finish up the wiring so we can do a test load. I think that's about it. Alright, let's get started. Before we get too far in today's video, I just wanted to give a quick update on cell 13. It's held a charge perfectly fine. It's not discharging itself. It's held a charge for over 24 hours now. So I believe it's fine. I think it just was the first pack that I made and sat the longest. I'll keep a close eye on it no matter what, but that's what I think. You can see it only went up to 4.06, which is fine because I don't plan on charging these all the way up to 4.1. I will probably stay around maybe 4.02 or something, but most likely 4 flat. But anyway, just wanted to give you a quick update on cell 13 before I get too far into the video. Alright, so I just wanted to give you a quick overview. I have all the wiring done, so this would be negative in from the battery. Bus bar for the positive is wired up to the breakers, and then this would be positive in down here. So we're ready for we're ready to series the batteries, which I'm going to do now. So I am going to put the camera on a tripod and get started. Okay, the next step is to test the voltage of the entire battery bank as a whole. I'm going to do that now. This is the negative of the entire bank. Okay. This is the positive. Reading 57.3, which is exactly what I want it to be. Okay, now that we have the battery bank ready, the next step is plug it in. I'm not gonna lie, I'm a little nervous on this one. I do have a fire extinguisher on hand. Yeah. Let's hook it up. Okay. So other than throwing the breaker, it's fully operational. Three, 2, 1. It's on. The inverter is off. Okay. Push it on. There's a little power button for the inverter. I'm gonna press that on now. Kicked on. It has a green blinking light which indicates that it's in standby mode. All right, let's go look at the batteries right now, because in standby mode, the inverter should take up about 25 watts. So let's go see what the Batrium says. All right, at the Batrium, we could see that it sees the total voltage right where I was reading it at. The inverter is only pulling 5 to 6 watts at idle. That's a lot better than what the owner manual said. I was expecting around 25. I'm very happy with that, to be honest. Everything looks good so far. The next step, actually, let's go over to the inverter. Okay, so the next step is, now that we know the inverter works, this is the AC side. I'm going to quickly hook up a surge strip directly to it as a test. This is not going to be permanent whatsoever, simply to test it. But before I do that, I am going to shut everything off, and then I'll wire up the surge strip, and then we can put like a test light on it or something. So let me do that real quick. Real quick, I turned off the inverter, and before I did anything else, I ran back to the computer to show that the Batrium by itself is pulling 2.5 watts, which is pretty awesome. Anyway, I'm going to get to hooking up the test surge strip. Okay, I've temporarily hooked up the surge strip. This actually has a 20 amp breaker built into it. I got it on a brick, so it's elevated off the ground. I put a strap on it so it actually can't move. It won't fall on into anything. I temporarily wired it in. Like I said, this is not permanent. This is just temporary until I get my panel wired in. But I did buy a panel, and I actually have that on hand. I'll show you that in a second. But with this surge strip, we can do a test load on it. I'm thinking maybe this light that's been lighting my my scene. So let's give that a shot. First things first is turn on the batteries. Turn on the inverter. Let me turn the light on. Turn on the inverter. This little power button right here. I didn't turn on. Oh, there it is. I didn't press it hard enough. Alright, so now that it's on, let's test the light. So right now we're pulling like we were before. Oh, actually 27 watts, which is exactly what it said it was going to do. Maybe now that I have AC hooked up to it, it pulls the proper amount, because it's supposed to pull, oh, it jumped down, 25 when it's idle. The Batrium pulls about 2.5, so that would have been right. Let's plug in the light and see what happens. Ugh. All right. It's on. It's powering the light. It's LED light, so it's nothing special. But let's go see what we're pulling. 36 watts. That's not too bad. Let me see what else I can test. Okay, so I have a box fan that I use up in the attic of the shop to pull all the hot air out of the shop. That's on this extension cord right here. With that plugged in, we're now pulling 112 watts continuously. You see, batteries are doing pretty good. Alright, like I said earlier, I did buy a breaker box for the AC load, just to show you that I am using the surge strip right now as a temporary solution. This actually has a 100 amp breaker on it. I'll never need 100 amps, but I couldn't find anything that was less. Plus, with a 100 amp breaker, it gives me something to move forward to, so if I ever add another inverter or anything. So this is a very good panel, and I think it's going to work nicely with the setup. So anyway, that's the panel I have. I'm getting ready to show or turn on a bigger load. I will show you that now. Okay, so currently drawing about 170 to 180 watts, 3 amps. What I did is I put my laptop, which that's what we're looking at this right now. My laptop's on there, and I have this other fan. Behind it, though, is the air conditioner. I'm going to turn that on, but first, I want to check the temperatures of everything. Make sure that with 200 watts, everything is good. So let's test. I don't know if you can see the laser light on the screen. 73, 73, 73, 73, 76. So a little bit more load on the positive side, which I'm not surprised by. But the good thing is the bus bar itself and the lugs are the same temperature, around the same temperature. Don't see a huge jump, which means that's good. Batteries are good. Everything's good so far. Breakers. Yeah, everything looks good. And that's with 200 watts and about 3 amps. Well, not 200 watts. I'm rounding up too aggressively. About 180 watts if I round it up. 3 amps. Cells seem to be handling it just fine. Do I kick it on? I think we can kick it on. And this is going to probably draw around 1,000 watts. So this is a pretty good test. Alright. Alright, kicked on. That's just the fan. Hasn't kicked on the compressor yet. Oh, I probably have to set the temperature since I turned it off. Let's just crank it down. Should kick on the compressor here. So with it just running the fan, we're at 230 watts. 4 amps. should kick on any minute. Well, let's just dial it down more. Oh, there it went. There we go. 1,300 watts. 22 amps. We're currently at 0.55 kilowatt hours. Well, let's go test temperatures while it's pulling that. 72. 72. 75, 77. So even with the additional draw, the positive side has stayed around the same temperature. That's pretty darn good. Let me check the breakers. Whoops. I'm trying to test the lugs on the 72. Inverter is not getting warm at all. Let's look at the batteries. It's looking really, really good. Still falling. 1,400 watts. That's amazing. It's crazy to see a project that you've put so much work into work like right out of the gate. That's like pretty awesome. I'm going to let this run for a while. And I'll come back. I mean, everything looks good. I don't see anything alarming right now. I'm going to keep my eye on it, and I'll give you guys an update. Okay, another quick update. We're still discharging around 1,400 watts. I just want to point out, look how balanced the cells are. This one, it was lower than the rest, but it's staying consistent, so it's not draining quickly any quicker than the rest of them. So that is a good sign. And once I set my threshold, so they're all balanced, then they should all discharge the same rate. But we're approaching 1 kilowatt hour, well, half a kilowatt hour. I'm just gonna keep watching it. All the temperatures are really good. It's currently 71 degrees in my shop, and the highest temperature on any component is 75. So looking really good. And that's Fahrenheit, freedom units. So anyway, I'll keep you guys updated. I probably won't extend this video too long, but I have to go to work in the morning, and I'll probably have to shut everything off here soon. So I'm just going to discharge it as much as I can. Okay, so I noticed something a little weird. I added my shunt temperature on there. So it says it's 42 degrees Celsius, and that does not match at all what I'm seeing. So I'm going to turn on my little test meter. And this thing is actually pretty accurate. It's off by maybe half a degree at the most. So I'm showing 75 degrees on that. That's Fahrenheit. Let me switch over to Celsius for you guys. We're showing, 24. Even the internal, if I test the little black box on the side of it, it's showing like 24 degrees Celsius. So I don't know why that's reading so high. It's literally not that warm. It says it's 42 degrees Celsius, and that's not the case. So I don't know if it takes like an internal temperature, or I have a bad reading on the shunt temperature. But anyway, everything seems to be working good. Everything's discharging evenly. I'm very happy with it so far. Okay, last update for this video. I have to get ready to go to work tomorrow, but the air conditioner has kicked off because it's cooling down outside. And apparently it cooled it down to 69 degrees in here, which is what I had it set to. So just with regular stuff going, the test load's at 250, 260 watts, only 4.7 amps. Everything's still running really cool. No complaints. We discharged 1.3 kilowatt hours so far. And the battery voltage still looks really good, so I think we're in really good shape. The next video I am going to hook up the charge controller, because that's the next item we need to test. Thanks for tuning in. If you enjoyed this video, please give it a thumbs up, like the channel, subscribe. The next video is going to be charge controller and hooking up the solar panels up to it, because that's the next step that we need to test. But stay tuned for more updates, and thanks for watching. I appreciate it.